So there's two formats of quadratics that I know you're familiar with. One is I think the book calls it standard form. Truthfully, I call this vertex form. That's the one with HK, where HK is the vertex. So f of x equals a parentheses x minus h squared plus k. So hk is your vertex, and then the only other piece of information it really gives you is it gives you the vertical stretch, compression, or flip. So that's why if a is greater than 0, aka positive, it opens upwards, because the parent graph opens upwards, and if you didn't negate it, then you never flipped it upside down. I don't know if you have ever made the connection between the meaning of the a value and stretches and compressions and transformations, but it's there. And then if a is less than 0, it opens down. Does that make sense? Okay, because you've put a negative out in front, you flipped it vertically. To go a little bit more in depth with a, just because we can, if the absolute value of a is between 0 and 1, the parent graph is 1x squared, technically. So if a is going to go smaller than that, like a half of x squared, what does putting a 1/2 out in front of a function do to it? Aiden? Right. So if you have an f of x and then you have a 1/2 f of x, it more specifically vertically compresses it, yes? And a vertical compression on a parabola, if there's your parent graph, a vertical compression is going to bring all these points halfway down, and it's going to make it, just loosely speaking, look wider and fatter, yes? So if a is, or the absolute value of a, so this covers the negative part as well, if it's between 0 and 1, then it's a little bit wider. And I know you guys did this, but you probably never associated it in Algebra 1 with stretches and compressions and stuff. And if you have like a 5x squared, that makes it taller and skinnier because that stretched it vertically by 5. So if the absolute value of a is greater than 1, it's wider, skinnier? We'll go with skinnier. Spell skinnier, John. S-K-I-N-N-I-E-R. Nah, I gotta fact check myself here. You got a Y in it?
I think it might be what it just be
more skinny. Skinnier? I feel like I use that word. Yeah. It's funny because do you ever write it? Absolutely not. But we are in math class today. And now just out of curiosity, because if I don't look these things up right away, skinny, oh, what just happened? Skinnier, S-K-I-N-N-I-E-R. We are good. Okay. Our other form. That's okay. Oh, very important. Okay. Are you done though? Awesome. It's okay. All right. So f of x equals ax squared plus bx plus c. And this is the one that you're most familiar with in terms of using the quadratic formula, where you use a, b, and c to plug in and find your roots or your zeros or your solutions, whatever you call them. This one, just looking at it, doesn't really give you as much. Getting the vertex from this one is pretty powerful. The a's all mean the same thing, because it is the same a value, by the way. Your c is just your y-intercept. Okay? That's what this one gives you that this one doesn't, just by looking at it. Your c value, whatever that is, that's your y-intercept. Okay? In order to find the y-intercept, once it's in this format, you have to plug in an x of 0 and then go through and crunch numbers. Technically, that's what you're doing here, plugging in a 0, and crunching numbers, but it just is always going to end up being c. Okie doke? Okay. So, graphing something from vertex form, what is the vertex of this first example, do you think, Joe? Say it again. That's not a 3, this one here. Sorry, that's an 8. 3, 8. Very good. Yep. So H is 3, 8 is K. Your x-intercepts. How do you always find x-intercepts? You set, if a point falls on the x-axis and therefore is an x-intercept, not x, y to 0. So to find an x-intercept, we set y to 0. So we would say 0 equals negative 2 x minus 3 squared plus 8, and we would solve this. And in solving this, what would I do first to both sides, Bridget? Subtract the 8. So negative 8 will equal negative 2 x minus 3 squared. Next, Nate? Very good. So that'll give us 4 equals x minus 3 squared. Olivia, next. Square root, and what will that give us? Plus or minus 2 equals x minus 3. And then last step, adding 3 to both sides, Sarah, what will that give you as your two answers? 1. Very good. Now, for the record, and I know you know this, whether you take the time to check it or not, I don't know, but your two roots should be equidistant from your vertex's x-coordinate, right? There's your 3. 5 is 2 above, and 1 is 2 below. So that makes sense, right? Because the vertex is right down the middle of A. And by the way, that's where that 3 comes from, right? It's 3 plus or minus 2. So you go equidistant 2 above 3 and 2 below 3. And obviously that 3, if you trace it back, that's where the vertex's x-coordinate came from. So if I plot my vertex, and then plot my x-intercepts of 5 and 1, I've got the general shape, but I'm going to perfect this just a little bit more. Who thinks they can tell me what an axis of symmetry is? Olivia? Yes, it comes from the x-coordinate of the vertex, but it is the equation of a line, a vertical line that goes through the vertex, yes. So x equals 3, really what you're doing when you write the axis of symmetry is you're writing the equation of a vertical line. So you would never want to just say 3 is my point. You wouldn't say axis of symmetry 3. You have to write the equation of that line, x equals 3. And it is what it is, like it's a line that the parabola is symmetrical around. And then the y-intercept, which we have to do what? If the x-intercept, we plug in a y of 0. For the y-intercept, we plug in a x of 0. So we're just going to do negative 2, 0 minus 3 squared plus 8. Negative 2 times 9 plus 8. Negative 18 plus 8, negative 10. That's going to be pretty tough to get on our graph. The point is, by the time we get to our roots, the slope of this is pretty darn steep because we're going to have to go down 10 over 1 before we get to our y-intercept. So we're just going to call it a day right there. Any questions? Okay. How do we find our vertex in the other format? Give it a whirl, Marissa. So So you could take this function, complete the square, but you just would be turning it into this and then stealing the vertex. So I want to ask you if you know how you find the vertex from this format without doing that. There's like a little formula that you should have learned in Algebra 1, probably. I do it with my Algebra 2 kids just because I think it's good to know, but I don't know that we necessarily have to do that. So I'll write this over in the column where it's easier to see. You're going to get your vertex first by getting the x-coordinate. And the x-coordinate of the vertex, so I'll do x sub v, so that's the x-coordinate of our vertex, equals negative b over 2a. Raise your hand if that sounds familiar. Okay, so did you do that last year? Okay, like I do with my Algebra 2s. It might have been mentioned, but we don't really like drill you on spirals and stuff. All right, so negative b over 2a. So in this case, negative b would be negative 4 over 2 times negative 1 would be negative 2. And then that division will just give you an x-coordinate of 2. And how do you find the corresponding y-coordinate then? If you know an x-coordinate, what do you do with it to find the y-coordinate? Plug it in. So if I plug in a 2, that's going to be negative 4, once I square it, plus 8, because I do 4 times 2, plus 1, which is going to just be 5. So for the record, without completing the square, I could very easily tell you what this function now would look like in vertex form. Because my a value is what it is, that doesn't change, and it's x minus 2 plus 5. So I can actually get there without completing the square using that little negative b over 2a trick. Okay? We couldn't avoid completing the square in Algebra 2, really, because then you also had to complete the square on a circle, so it was just all kind of a similar concept. So anyway, now x-intercepts. How do you find an x-intercept from this format? Well, we say you always, to find an x-intercept, set y equal to 0. 0 equals negative x squared plus 4x plus 1. How do you solve that? Mitch? Quadratic formula. If you look quickly and try to think, is that factorable? It's not. So I'm going to do the quadratic formula over here just because it's going to be easier to see. Negative b is negative 4, plus or minus the square root. B squared is 16 minus 4 times an a of negative 1 times a c of 1. All over 2a, in this case, is going to be negative 2. Now, be careful here, because for the first time you guys don't have a calculator when you're trying to compute the discriminant. And there's some sign complications going on here, right? The discriminant is this section under here. 16 minus 4 times negative 1 times 1. So because in this string there are two negatives will make a positive. So it's actually going to be 16 plus that product 4. Yes, 16 plus 4 is 20. And then if we reduce root 20 to 4 times 5, it'll be 2 root 5. Now, for the record, I don't know if you guys know this about the quadratic formula, but this is your negative b, right? And on the bottom is your 2a. That's where your vertex, and this is not how you usually would see it, right? But there's your negative b over your 2a. Whoops, don't do that. There's your negative b over your 2a, plus or minus the square root of b squared minus 4ac over 2a. So there's where that x coordinate of your vertex comes into play, right? That'll give you negative 2. Oh, what's wrong? Oh, I dropped my negative. Sorry. That will give you 2. Does everyone make sense of that? And then plus or minus, because your vertex is in the middle, when you add 2 root 5 over negative 2 and you subtract 2 root 5 over, it'll keep it symmetric. So it's going to pull from your vertex your zeros symmetric to your vertex on either side. Yes? Just, again, connections that probably have not been made for you, or at least not made sense maybe. So I'm just showing you logically kind of where that negative b over 2a comes from. It does come from the quadratic formula. Anyway, we would simplify this to, we would divide both terms by negative 2. So negative 4 divided by negative 2 is 2, plus or minus 2 root 5 divided by negative 2 is just going to be root 5. You don't really have to worry about the minus there because the plus and the minus sign kind of covers both. I mean, technically maybe it would flip it to minus plus, but we don't do that. So we would just say root 5. So we have to graph this and we don't have a calculator. 2, 5 is no problem. I'm going to get the vertex there. But my x-intercepts need to be in the ballpark, meaning they need to be between the proper two integers. So where is 2 plus root 5 going to fall? Between what two integers? Bailey, what's your thought? And you don't know because you don't know what? Square root of 5. Do you know the square root of anything that's near 5? Okay, so the square root of 4 is 2. So if you had to guesstimate, what would the square root of 5 be? Ish. Closer to which one? You know root 4 is 2, and you know root 9 is 3. Right, because root 5 is closer to root 4, so your answer, so 2.1, 2.2, something like that. The fact of the matter is we don't have to be that exact because we're not, on a perfect decimal, number line. But 2 plus, let's just say 2.1 would be 4.1. And 2 minus 2.1 would be negative 0.1. Good? We're going to keep our x-intercepts written as 2 plus or minus root 5. We're not going to use our guesstimated decimals, but we have to guesstimate to get those on the graph. Okay, axis of symmetry. Morgan? X equals 2. Very good. And your y-intercept, Trista? 1. You can take the time to plug in 0 if you'd really like, but you could just grab your C value. So that gives me a point that actually fits on this graph. And actually, as long as you're doing it and you have your axis of symmetry right down the middle, you might as well find the point that's symmetrical to that on the other side just to make sure your graph stays, balanced. So 2 to the left, 2 to the right, and there would be your parabola. So I don't know if you've ever had to graph parabolas without a calculator attached to your fingers, but now you do, okay? All right, what do we got in the back? Oh boy, I didn't realize this was coming today. Don't worry, it's fine. These are going to be kind of like our word problems from last chapter. But now we're actually not just writing an equation, we're going to use the equations that we write to answer a question. So, you have 100 yards of fencing to enclose a rectangular region. So those four sides need to add up to 100. So if you want, you can do x, x, y, y. 2x plus 2y equals 100. Okay, we want to maximize the area. So the equation that we are maximizing is this one right here. The issue is, just like we ran into last time, but they won't explicitly tell you this, is you can't maximize something that's in terms of multiple variables, right? We can maximize the area once it's all in terms of x or all in terms of y. And really, this is where half the class could go one way and half the class could go the other way. You could choose to sub out the x and replace it with a y thing, or you could take out the y and replace it with an x. It doesn't really matter. Like I said, we might split here, but let's just solve one of these. I'll solve for x. So 2x equals 100 minus 2y, divide by 2, x equals 50 minus y. So now I will use that back in here for x. So what that just did for me, if I do distribute, or I don't have to, is it gave me a formula for the area based on just the y coordinate alone. Okay, so if I'm looking at a graph and I were to graph this parabola, now this is a little confusing because the y-axis here is actually our area, right? And we just, maybe I should have used L and W to prevent this confusion, because my y-coordinate here, which is my width, right? If we do length, width, that actually is my x-coordinate. I just happen to be calling it y, if that makes sense. So maybe you want to avoid x and y and use L and W. But, so, we all can agree this is a quadratic, this is a parabola. If you see words like maximize and minimize, you're being asked for the vertex, essentially. I don't know necessarily which part of the vertex. We'll have to figure that out. But right now, when we get our vertex, the x-coordinate of our vertex is going to be the y dimension, our width. And the y-coordinate of the vertex is going to be the area at that width. Does that make sense? So you can find your, actually here, you could find your vertex in our traditional way, which would be negative b over 2a, which would be negative 50 over negative 2, which would be 25. So that's the y-coordinate of your vertex. And then you'd plug that back in to find your area. Now, I'm going to go out on a limb here and say that none of you know what 25 squared plus 50 times 25 is, or maybe a couple of you do, but the rest of you are going to sweat without a calculator, correct? I might sweat a little bit without a calculator on that one, which is why I wouldn't use that one. I would go back here, because if you know y is 25, 50 minus 25 is 25 times 25. No. 25 times 25 is 625, I believe. Yeah. And if you don't know that, it doesn't hurt you too much to have to go and do long multiplication. So, if I go back to my image, this being 25, and my area being 625, tells me that my length, 25 times what would give me 625, my length actually would also be 25. So find the dimensions of the rectangle that will maximize the area. The dimensions are length times width. So the dimensions are 25 by 25. And what is that maximum area is 625. Now, they usually won't ask you all of those. They might just ask you what length will maximize the area. They might say what width will maximize the area, or they might say what are the dimensions, in which need to include both, or they just might say what's the maximum area possible. You just have to read the question and pay attention to what they're asking for. Okie doke? Okay. A car rental agency can rent every one of its 200 cars at $30 per day. For each $1 increase in rate, 5 fewer cars are rented. Find the rental amount that will maximize the agency's daily revenue. What is that maximum daily revenue? So they are asking 2 questions here. So I'm going to totally change up how I teach you this. In the previous chapter, those word problems where you were just writing the equation were pretty specific with you in saying that when X is the whatever, the price per day, or yeah, right? They said something like that. They told you what X had to be, so we had to follow suit. I do think what they told you X had to be made it more confusing than it needs to be. So I'm going to show you this in a totally new light. Right now, your revenue is 200 cars. That's your number of cars. Times the price per day, right? 200 cars, each spending $30. Okay, right now it's like a $6,000 revenue day. Does that make sense? Okay? But that is going to change. That's why I left parentheses there with some space. And this is where I'm going to handle the increasing scenario. So there's my initial scenario. And I like to put this there so I know what each parentheses kind of representing. So every time the price, this $30, increases by $1, X now is going to be the number of times that we do that. So X is the number of price increases. And those are $1 each. So I'll just say of $1. Every time you add $1 to the price, so X times you do that, you're going to lose 5 cars each time. So X here is not the number of cars, it's not the price. X is the number of price changes. Does that make sense? And so there's my quadratic. Good? Now, question is, maximize it. Before we maximize it, one of the biggest places I feel like kids lose themselves in this kind of problem is I have no problem thinking that you can maximize this by finding the vertex and by plugging that x coordinate back in and find the y coordinate. Where I lose kids is when they give me the vertex, they don't know what each coordinate stands for. So before we do that, I want to be clear that the x coordinate is going to stand for the number of price increases we undergo, and the y coordinate is going to be the revenue that is brought in under that condition. Does this make sense? Okay? So have your eye on that so that when you calculate your numerical vertex, you know what the heck your x coordinate stands for and what your y coordinate stands for, so that you can answer the question accurately. So from here, now I can FOIL this guy out. I would get 6,000 plus 200x minus 150x minus 5x squared, which would clean up to that right there. And then I can do negative b over 2a. Yes? So negative b over 2a is negative 50 over negative 10, which is 5. So right now I already know if I want to maximize my revenue, I want to let there be 5 price changes of $1 each. In other words, I want to up the price by $5. Yes? In doing so, I'm going to lose 25 cars, but that's okay. That's what will maximize my profits, right? Making $5 more per car on 175 cars is more significant than losing 25 cars at $30. That's kind of what that all just did. And then to find my y coordinate now, again, plugging 5 into this would be a little bit challenging. Plugging 5 into here, maybe not the easiest either, but that would be 175 cars at $35 each. So you would just definitely need to do long multiplication there. So 5 times 5 is 25, carrier 2, 35 plus 2 is 37, carrier 3, 5 times 1 is 5, plus 3 is 8, fill your 0, remember all this fun stuff? 3 times 5 is 15, carrier 1, 3 times 7 is 21, add 1, you get 22, carrier 2, 3 times 1 is 3, plus 2 is 5, add them all together. 6125. And maybe that would have been easier here. I don't know. It's up to you. So to answer the question, find the rental amount. Well, if there are 5 price increases, and this is where I'd have people say, oh, the rental amount needs to be 5. No, right? That's where they lose track of what everything means. There's 5 price increases, which means the rental amount is $35. And they also ask for what the revenue would be in that case, which is the $61.25. If they had asked how many cars you would need to rent, then you'd plug into the number of cars section and you'd get 175. So 175 cars at $35 gives you a revenue of $61.25. Okay. Last thing, in the event that negative b over 2a and multiplying all this out seems overwhelming, how else can I use this to find the x coordinate of my vertex? What if I asked you to find your x-intercepts? Because this is in factored form, can't you just tee it up and see that your x-intercepts will be 40, right? 5 times 40 would give you 200 minus 200. And you'd also have another x-intercept at negative 30, right? If I tee this up, x would equal negative 30. If you have your 2 roots, where's the vertex relative to those? Halfway in between. So what's halfway in between? In other words, you could average 40 and negative 30. They add together to get 10, divide by 2 to get 5. So if you have it in factored form, you can find your roots and then just go halfway between them, and that's the x-coordinate of your vertex. So it all kind of, you know all this without knowing all this. Like, all this should make sense. Like, oh, I get that. Okay? Any questions? All right. I'm done with you.